Good morning, dears. Today is Tuesday, 17th of March 2020. We will talk today about kinetic theory of matter. You can find everything here in pages 110 and 111. Also, some you can find them in the pressure chapter, pages 74 and 75. The kinetic theory of matter, you don't need to memorize this, you need to understand it. As a statement, you don't need to memorize it. But they will ask you, what will happen if we heat a gas? So heating gas, this is what is written in the book, it's called heating gases. So as temperature of a gas increases, then what happens? Then its molecule gain more kinetic energy, so they will move faster. This is logic, and I believe that everybody do understand this concept. Now, note, any gas produces a pressure on the container. We mean the container that contains this gas. They may ask you why. This question may take 3 up to 4 marks. So we want to answer why the gas produces a pressure when we put it into a container. When we put gas in, let's say, a lighter, there is high pressure there. Why there is a pressure? Not high, why there is a pressure? The answer simply, it refers to the collisions between gas molecules and the walls of container. So many students, they say collisions between molecules with each other. This is wrong. We said there are no forces between molecules of a gas. So here, the answer will due to the collisions between gas molecules and the walls of container. Now, if you remember the word collision, we studied it in the chapter of momentum, which changes their momentum. As there is a collision, there is a change in momentum. Hence, there is a resultant force, because if you remember, we said resultant force equal change in momentum over time. Since there is a resultant force, there is a resultant force on the walls, and if there is a force, then there is a pressure, which creates a pressure on the walls. So if they ask you why there is a pressure on the walls, this is the answer, because gas molecules, they keep colliding. They don't only due to the collisions, due to the, let me write, the continuous, all the time, continuous collisions between gas molecules and the walls of container, which changes their momentum. Hence, there is a resultant force on the walls, which creates a pressure on the walls. Okay, now this is page number 1. Now, what will happen if we increase the temperature? If we increase the temperature, we said molecules will move faster. So as temperature increases, what we know that kinetic energy increases, kinetic energy of molecules increases. So molecules move faster, molecules are faster. Now, what is the result of this? In fact, there are 2 possibilities for this. Then, either or. what will happen? Either as they are moving faster, this will causes the pressure of the gas increases, but the volume stays constant, or the volume increases, the volume of the container, so the volume of the gas increases, but the pressure stays constant. Now, you are required to explain why this happened or why this happened. So as temperature increases, molecules gain more kinetic energy, so they move faster. As a result, pressure increases. Why? If they ask you why, the answer is due to more and harder collisions with the walls of container. This is why the pressure increases. So if they ask you explain why the pressure increases, the answer. If they ask you why as temperature increase, pressure increase, the answer. Because as temperature increase, molecules gain kinetic energy, so they will move faster, then there will be more and harder collisions with the walls of container. Collisions between the gas molecules and the walls of container. So due to more and harder collisions with the walls of container and gas molecules. We have to mention the collisions are between these two, okay? So this causes the pressure to be increased. So if I'm asking you how the pressure with temperature look like, it looks like something like this. Maybe it's curving, I don't care if it's curving or straight. Maybe it's curving, maybe it's straight, but the idea, it's never zero because there is no pressure equal to zero. And as temperature increase, pressure increase. We don't say they are directly proportional, but we say as temperature increase, pressure increase. Because we said directly proportional means it starts through the origin. Now this is not through the origin. Okay. Or there is another option. As temperature increase, what may happen? Okay, what will happen 100%, the kinetic energy will increase and molecules will move faster. Then maybe the volume will increases, but the pressure stays constant. Why? Due to more separation between the molecules. So the molecules will move further apart, causing the container to expand, and as the volume increases, the volume of the gas will increase. So if they ask you, a gas is heated, its temperature increases, explain what will happen. You don't say or. You have to mention this or this, but you can't say the word or. You have to judge whether this will happen or this will happen. How can I tell what will happen? Now here volume and temperature, it's still the same thing. Yeah, how can I tell what will happen? Listen to me. It depends on the type of container. What do you mean, Ustaz? If the type of container, if the type of container is fixed in volume, let's say like this. If I have, this is container, and here we have gas, and there is heat. What will happen? Here, we are sure temperature increases, kinetic energy increases, molecules move faster, speed is faster. This is speed, huh? This is speed, بلاش تفكروها velocity. Speed increases. So pressure increases, but the volume is constant. How could you tell, Ustaz? Because it has nothing there. It's the box is sealed box, sealed container. But if the container was like this, do you know the syringe part that we use it in medicine, this one that it has the needle inside? Let's move the needle. Now here we have the black thingy there, rubber, that holds the liquid inside. Now this is, they call it piston. And since the piston can be pushed in or out, so we'll call it movable piston. Now if we are there in the lab and we pull it up, then here air will come in, and let me put something here to close this end. Now let's say we put it into hot water, so now it's heated. Now what will happen here? If temperature increases, the kinetic energy will increase, so speed increases. So the molecules will hit this wall more. What will happen? Nothing. Will hit this wall more. What will happen? Nothing. Will hit this wall more. It may open. If it does not open, it will hit this more, so it will move upward. It will move to this side. So now the air is filling greater volume. So volume increases, but pressure stays constant. So these are the two possibilities that would happen. So what happened after temperature increase? Either this or that, but you can't say either or, you have to say only one, depends on the case. If it looks like this, if you know that it's sealed container, sealed container, then it will look like this. If it was, if it has a movable piston, it will happen like this. Okay, now the last thing, what will happen for pressure and volume, but now if the temperature stays constant. Now, this is a law. We don't care about the name of this law. Now this is in page 74 and 75. The beginning here, it was, this is pages 110 and 111. Now this is page 74 and 75. Now there is a law, its name is Boyle's law, the name is not important. You need to know that for a constant mass of gas, which means gas is enclosed in somewhere, for a constant mass of gas at constant temperature, so the temperature is not changing, then the pressure, gas pressure, is inversely proportional to its volume. What does this mean? This means pressure, if you remember, this is directly, but when we write it this way, it becomes inversely. So pressure is inverse to volume for constant mass and constant temperature of a gas. What does this mean? What do we mean by inversely proportional? Means if one increases, the other will decrease at the same rate. So pressure times volume equal to constant. What is this constant? We don't know. We don't need to know it. It's varying from one constant to another constant. That's pressure times volume. So if we have a certain gas at certain pressure and certain volume, so they have this gas that has certain pressure and certain volume, and then we change the pressure, then immediately the volume will be changed, so that the total P1 times V1 equal P2 times V2. I will show you a question how to use this calculation. I told you before, this unit, it has little calculation. This is one of the calculations there. Everything before it was for memorization. Now, this is, you have to memorize this equation to know how to do it. Now, before, if I'm telling you, if I have pressure here and volume here, how does it look like? Inverse proportion means like this. It never touches the pressure or the volume. But if it was pressure with 1 over volume, it will be straight line through the origin, or even if it was volume with 1 over pressure, برضو كمان it will be straight line through the origin. Okay, I'll go back to the graphs later on. Now let me show you a question about this one. 5. They will ask you like this question. A cylinder contains a gas of volume equal 55 centimeter cubed. Its pressure is 1.5 times 10 to the power of 5 Pascal, as shown. They give you, this is the cylinder, here we have gas, it has this movable piston, this is the piston. Let me draw it here in red. Now this is movable piston. Now if I push the piston inward like this, a student pushes the piston slowly inward. Slowly, remember with me, slowly to keep temperature the same. Yani, this is the way, how do we keep the temperature constant? By pushing it slowly. Inward, this means the pressure will increase or decrease. If you push it in, surely it will increase because there will be less volume. So, the volume decreases to 27.5 centimeter cubed. Calculate the new pressure. Now, how do we do it? Here we have 2 pressures and 2 volumes. The pressure at the beginning, this is P1 and this is V1. So the pressure, it was 1.5 times 10 to the power of 5. The volume was 55. Now the pressure, we want to know what will happen to the pressure, but if the volume now becomes 27.5. Now simply you just divide by 27.5, divide by 27.5. These cancel out, so P2, just do it on the calculator, you will find the answer as 3.0 times 10 to the power of 5 Pascal. Now, the pressure has been increased because the volume decreased. Do you see? You see, volume 2 is smaller than volume 1. Volume 2, this is volume 2. This is volume 1. Volume 2 is smaller than volume 1. So pressure 2 will be bigger than pressure 1. So this means they are inversely proportional. It is simple. I wish that you do understand all of this. Now they may ask you the last thing. They may ask you, explain, another question, explain why as volume increases, the pressure decreases. The question, the answer is just like this. As volume increases, the rate of collisions between gas molecules and the walls. Do you see how many times I say the walls? It's important. Without the walls, you don't you lose the mark. As volume increases, then the rate of collisions between the molecules and the walls decreases because there is more volume, so less number of collisions, which decreases the forces on walls, again on walls, so pressure decreases. We may say which decreases the forces on walls due to less momentum. So pressure decreases. يعطيكم العافية. I will send you a few past papers to try to solve them about all of this, and I will show you the answer later on. يعطيكم العافية.